So can one of you tell me what is, so before going into relation, what is Cartesian product? So if I have a set A and B, you can see my screen, right?
Yes, sir.
Yeah. So what is the definition of A Cartesian product B? Anyone?
Hello.
Yeah.
Sir, basically first element from A and second element from B.
Yeah, it's basically the ordered pair where the first element comes from A and the second element comes from the set B. Okay. And this is the Cartesian product. I don't know. What did you show? Just give me a minute. Yeah. So if I have a set A and B, so the Cartesian product is nothing but the ordered pairs where the first element comes from the set A and the second element comes from the set B. So once I have this Cartesian product, then what is the relation? Relation is the relation from A to B is nothing but it's a subset of. So relation from A to B is nothing but it's a subset of A times B, right? So so there are bunch of different types of, there are basically different types of relations. So the first one is identity relation, right? So when we basically talk about identity relation, that means it's a relation from a set A to itself. Okay. So this identity relation we can only talk about when we have a relation from the set A to itself. And when I say, suppose I have a relation I, and I, which is of course is a subset of A cross A, then I can say that I is a identity relation if I is precisely same as this set, right? A comma I, which is inside A T, right? So if my relation is precisely this set, then I call that relation as a identity relation. So for example, if I take my A to be 1, 2, right? Then I, the identity relation, which is a unique relation. So this relation, this is precisely the identity relation on the set A. Right? So if, for example, if I take some I star, which is 1, 1, 2, 2, and 1, 2, then this is not an identity relation because I have this pair where both the coordinate don't match. Okay. So the next one is reflexive relation, right? So anyone, what is the definition? Again, the reflexive relation you can define on a set, on a relation which is basically from the set A to itself, right? So can one of you tell me what is the definition of reflexive relation?
Yeah, A comma A belongs to set R.
Correct. So a relation R on A is reflexive if A comma A is in R for all A in A, right? So in particular, what basically it's saying that if the identity relation is a subset of the relation R, then I can say that R is a reflexive relation, right? So again, like if I take the same set, let's say 1, 2, and if I consider this set a relation R, which is 1, 1, 1, 2, and 2, 2. Right? So as you can see, I is a subset of R, right? I is a subset of R because you have 1, 1, and as well as you have 2, 2, right? So that's why this relation R is a reflexive relation, right? So for example, if I take this relation R, let's say 1, 1, this is not a reflexive relation because as you can see, this one is missing here. Okay, so I can say a relation is reflexive if and only if this relation contains the identity relation. So in this case, this relation doesn't contain the identity relation. So this is not a reflexive relation. And the next one is symmetry. So when you say a relation to be symmetry,
Sir, when A is related to B, then B should be related to A.
correct. So suppose I have a relation. If this is there, this should imply that if I flip the order pair, then that should be also inside the relation, right? So then only I can say that my relation is reflexive. So in other words, if R is related to, sorry, A is related to B, then this should imply that B is also related to A, right? So for example, if I take this set, let's say 1, 2, 1, 2, 3. So as you can see, if I suppose, so this is the cardinality of this set is 3. So let's define a relation 1, 2, 2, 3, 3, 1, and let's say 3, 2. So is it a reflexive relation?
No, sir.
No, right? Because as you can see, this 1, 2 is there, but 2, 1 is not there, right? So this is not a reflexive relation.
Not a symmetric.
Sorry, not a symmetry relation. Correct. Not a symmetry relation. So so instead of this relation, if I consider this relation 1, 2, 2, 3, let's say 3, 2, and 2, 1, then as you can see, this relation, this new relation is a reflexive relation because I have 1, 2, and I have 2, 1, right? I have 2, 3, and I have 3, 2. Okay, so if I flip if I change the order of the order pairs, the elements of the order pairs, then it's not going to affect much. Okay, so the new element is still inside this relation now. So that's why this is a symmetry relation, right? So the last and relation, standard relation, is transitive relation, right? So what is the definition of transitive relation?
A is a subset of B or C.
Sorry.
A is a subset of B.
Hmm.
B is another subset of C. So it all belongs to the set R.
Okay, so you are actually giving, in some sense, you are giving an example of a transitive relation. Now, what I'm asking, I'm asking the definition of transitive relation. So what basically it says, suppose I have a relation R,
So
when
if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R.
and B comma C is in R,
Then A
Then-
comma C belongs
correct.
to R.
then A comma C should be inside R, right? So this is the definition of transitive relation. So again, let's take a relation on the set 1 comma let's say 1 comma 2 comma 3. So this is my set. So let's say 1 comma 2, 2 comma 1, 3 comma 3. So is it a transitive relation?
No.
No, right? Because as you can see, if you pick this, if you think this as A comma B, and if you think this as B comma A, right? Then by the definition of transitivity, then A comma A should be inside R, right? That means 1 comma 1 should be inside R, but 1 comma 1 is not inside R, right? That means R is not transitive. So what about whether R is reflexive? Whether this relation is reflexive?
No,
No.
sir.
Yeah, what about symmetry? Whether this relation is symmetry?
Yes, sir.
Yeah,
Yes, sir.
it's symmetry, correct. So again, like let's consider one more relation. 1 comma 2, 3 comma 2. Let's say 3 comma 1. Yeah, what about this one? Is it transitive?
Yes.
Is it transitive?
Yeah,
Yeah, it is transitive. Yes, sir.
Right? Because see, the thing is, okay, so you pick 1 by 2. So if you think this as A comma B, then you have to find some B comma C, right? So there is no B comma C here for this 1 comma 2, because there is no such order pair which starts with 2, right? Because here this starts with 3, this starts with again 3. Okay, so again, I don't have to check anything for this order pair. So next you pick 3 comma 2. So again, the same logic. If I pick 3 comma 2, and if I think this as my A comma B, then there is no order pair of the form B comma C, right? So the last option is 3 comma 1. Now, yeah, there is one. If this is my A comma B, there is one order pair which starts with 1. So this is the 1 comma 2. Then this transitive relation says if A comma B and B comma C are there, then this should imply that A comma C is there. So the A comma C is 3 comma 2, which is inside R. So that means the relation is transitive relation. Okay. And if I have a relation, okay, if I have a relation which is reflexive, transitive, and symmetry, then you say that relation is a equivalence relation, right? So once you have a equivalence relation, then the relation, so out of a equivalence relation, actually you can get a partition, and if you have a partition of a set, then that will give you a equivalence relation. So this equivalence relation and partition of a set, they are basically in one-to-one correspondence. Okay. And okay, so let's next talk about this anti-symmetry relation. So what is the definition of anti-symmetry relation?
Sir, if A comma B belongs to R, then B comma A does not belongs to R.
No, that is not correct. Okay, in some sense.
Which is not symmetric.
Yeah, that is what I am saying. Well, what what basically you mean that which is not symmetric? Tell me what is the definition. So you are saying if a relation is not symmetry, then it's not anti-symmetry.
Yes, sir.
Yeah, that is also in some sense is incorrect. See, this basically says if a comma is in R, okay, and b comma is in R, that means a should be equals to b, right? So there is a huge difference, right? So what it's saying, okay, so you consider this relation, okay, let's say you consider this relation 1, 1, right? So if you pick a comma b, if you think this as a comma b is there, and as well as b comma a is also there, right? But again, it's not violating the condition. So a comma b is there, b comma a is there, and at the same time they satisfy this condition that a is equals to b, right? So that's why this is a anti-symmetry relation, okay. And at the same time also you can say that this is a symmetry relation, right? This is a symmetry relation. So it's not correct that if a symmetry relation is not symmetry, that doesn't imply that it's anti-symmetry. So at the same time, a relation can be both symmetry and anti-symmetry. Okay, so for example, if I take this relation 1, 2 and 2, 1, right? So this relation is not anti-symmetry because what basically it's saying 1, 2 is in R, a comma b, right? If we think this as a comma b comma a is in R, right? But a is not equal to b, right? Because 1 is certainly not equal to 2. So this is not this is not anti-symmetry relation, whereas this is a symmetry relation. Okay, so there is slight difference between anti-symmetry and symmetry relation. Okay, any doubt so far?
No,
Sir.
sir, this is a little confusing, sir. Can you please repeat this symmetry and anti-symmetry once again?
No, symmetry, I guess I have repeated, right? So symmetry, I guess it's clear to you, right? Because it's what basically symmetry is saying. If a comma b is in R, right? Then this should imply b comma a is also in R, right? This is what symmetry is saying. So for example, if I take this relation, so for you take this relation, whatever I have written. So if you think this as a comma b is in R, and if I change the coordinates, so if I flip the coordinates, then b comma a, which is 2, 1, that is also inside R. And same thing will happen for this pair as well. If you treat this as a comma b, and if you flip the coordinates, then 1, 2 is in R. So this is symmetry relation. Okay. And what is anti-symmetry relation? Anti-symmetry relation is saying if a comma b is in R and b comma a is in R, then this should imply that both the coordinates are equal. Okay. So here what is happening? 1, 2 is in R. Okay. And 2, 1 is in R. If I flip, then I will get 2, that is also inside R. But the problem is here both the coordinates are not equal, right? Here both the coordinates are not equal. So that's why this is not anti-symmetry. Not.
Sir, is identity relation is anti-symmetric relation?
Identity relation is anti-symmetry relation. Yeah, it's a anti-symmetry. Yes.
So, sir, that means all anti-symmetric relations will be symmetric, but reverse will not be true.
Sorry?
All anti-symmetric relations will be symmetric because b comma a will also exist in R.
No. See, again, you consider this relation 1, 2, right? So this is an anti-symmetry relation, right?
How is this anti-symmetric? B is not equal to A.
No, but the thing is when you need to check the anti-symmetry relation, what it's saying, if a comma b is in R, okay,
Yes.
and b comma a is in R, okay. If both the condition holds, okay, then you need to check whether a is equals to b, right? So here, first of all, this condition doesn't hold, right? A comma B is in R, but B comma A is not in R. So I don't have to check whether A is equals to B or not. I basically don't care. Okay. So in that case, this is anti-symmetry relation. Okay. Whereas this is not symmetry. What symmetry relation says? Symmetry relation says if A comma B is in R, okay, then this should imply that B comma A is in R. Now 1 comma 2 is in R, right? Whereas if I flip, then 2 comma 1 is not inside.
So how do I know 1 comma 2 is anti-symmetric?
Sorry.
How do I know that 1 comma 2 is anti-symmetric? Is it given to us, or we are? How do I deduce that this is anti-symmetric?
Just now I told, right? Why
This condition, so we are not checking. The condition that we are saying is that the second part is not there, so we are not taking. So
yeah, so then it's vacuously true, right? It's saying if this holds, then only I need to check it, right?
okay, so
So
that
if-
is not holding.
Yeah, so then it's vacuously true, right? So why I need to check?
So the condition doesn't hold, so we
No,
consider it as an
see,
anti-symmetric.
the thing is, it's saying if there is a, suppose the statement is if there is a man, if there is one person inside the room, then the person is a male. Okay. If there is no person, then vacuously this statement is correct, right? It's saying, so see, you have to understand this one. It's this if, okay, it's saying if this holds, then only I need to check. Okay.
Okay.
If this doesn't hold, then simply I don't have to check, right?
So I consider it to be anti-symmetric. right?
Anti-symmetry relation.
Okay.
Sir, my question is when it is A is equal to B, then it must be symmetric only. No, sir. How can it be considered as anti-symmetric?
Sorry.
In the given condition, if A and B belongs to R and B comma A also belongs to R, you are and it implies that A is equal to B. When you're giving the condition that A is equal to B, then it must be symmetric relation, no, sir?
Yeah,
How
so-
can it be considered as
Okay.
anti-symmetric relation?
Okay, so that you should check the definition. Okay, so I'm not saying anything new. Okay, so this is the definition of anti-symmetry relation, which is I'm saying. So symmetry relation is what basically say. If you flip it, then you should be inside the set. That is the natural definition of symmetry, right? Which is not happening here. Right? If I flip it, okay, then I may not get the element in the set, right? So there is a huge difference between symmetry relation and anti-symmetry. I'll suggest you try to see the definition of symmetry relation. Okay, so there is a definition of symmetry relation which is very natural. Okay, for this
Okay.
word symmetry.
Okay.
Okay, so the next thing is function. So yeah, so can one of you tell me what is the definition of function?
A rule that assigns one thing to other.
Sorry.
A rule that assign one value to other.
Yeah, so again, like this is a vague definition. I want see the only reason. So the reason we are studying relation is basically we can define function, right? So you need to define function in terms of relation.
For every element in the codomain, we have unique preimage.
Type of
You have
function.
unique preimage. Okay, so let me tell you. So function is basically it's a relation. So function from A to B is basically it's a relation from A to B, which is not one to many, right? So one element cannot maps to two elements. Okay, so this is not allowed for a function. Okay, so function is a relation which is not one to many, right? So for example, one cannot go to two, and at the same time one cannot go to three, right? So this is not allowed for a function. And once we have a function, so this part is called the domain, right? And this is the codomain, right? So codomain is the possible outcomes of a function. Okay, so codomain is, so the definition, okay, please mute yourself. So the codomain is the set of all possible outcomes of the function, whereas you have a range. Okay, so what is the range? Range is actually the set of all actual output of the function, right? So this is precisely the elements that comes in the output of the function. So for example, if I take this, let's say this map R to R, so this takes x to x square, right? So what is the domain of this function? So what is the domain? This domain is R, right? And what is the codomain? It's also again R. So can one of you tell me what will be the range of this function?
Positive R.
Yeah. So as you can see, so this -1 cannot be in
The
the
range.
in the range. Okay, so you can't get -1 as the output of the function, because you have x square, you will always get positive number, right? So as a result, this function, okay, so let me tell you. So once we have this, you have a function, then there are basically two different types of function. One is injective, one is injective. So injective means what? Different inputs will have different outputs, right? So if x1 is not equal to x2, if I have two different inputs, this will imply that my output are also different, right? And what is surjective function?
Codomain is equal to range.
Correct. So yeah, so in other words, you can say that for every element in my codomain, there exists an element in the domain such that f of x is equals to y. So in other words, this codomain is same as the range, right? So for this particular function, so whether this is a injective function? No, right? So as you can see, if I take 1 and -1, they basically goes to the same element.
Yeah.
Okay, 1. So here, if I pick two different, so I can pick two different inputs for which I can get the same output. So in that case, this is not 1. And what about onto? Whether this function is onto?
No.
Right? So this function is not onto. So again, let's take one more example. Like, okay, so maybe because you have studied this thing, 2x square plus 3x plus 1. So do you think this is a onto function? So do you think this is 1 function?
No, sir.
Why?
This is polynomial function.
Yeah. So again,
maybe,
so if I replace this by x, this is also a polynomial function, right?
sorry, that was quadratic function.
Not 1 for that x square term, it will not 1.
Sir, in quadratic equation, we will get two roots that will satisfy the same equation.
So you may not get real roots, right? You may not get real roots, right? So I'm considering this function from R to R. Right? So for example, again, if I take x cube, So this is, if I only consider this x cube, right? So this is a 1, 1 and onto function, right? So if you draw the graph of x cube, what is this? So this is both 1, 1 and onto, right? So again, I'm certainly mixing the concept. So if you draw the graph of a so this is a parabola, right? This quadratic function, this represents a parabola, right? So if you draw the graph, doesn't matter whether it crosses the x-axis or not, even if it doesn't cross the x-axis. So as you can see, right? So if you apply the horizontal line test, okay. So as you can see, you have two different inputs, right? For two different inputs, you have the same output, right? So this is not 1, right? And what about onto?
It's onto.
It's onto. Why? Why you think this is onto?
For every point we have image, pre-image, no?
For every point, you have pre-image.
This is not onto, sir.
See, the thing is, okay, so see, the y-axis actually represent your range, right? If you have a parabola, your y-axis, if you draw a graph, your y-axis always represent the range, right? So suppose you have a parabola like this, or suppose you have a parabola like this, okay. So this y-axis, so we are missing a lot of points, right? So you have, so all the points below below this point, okay, you are missing, right? This point are missing from your range, whereas all the points above this point is missing from your range, right? So certainly this can't be onto, right? There are a lot of points which you are missing, okay. So if I consider this, it doesn't matter, like if I take any quadratic equation,
Not a 1, 1 and 1, 2.
right? And of course, a is not equal to 0. So in this case, this is neither 1, 1 nor onto, right? So so instead of that, if I consider, let's say, so some linear function x plus 1 or x plus 2 or whatever, right? This is just a straight line. So this is both 1, 1 and onto, right? If I consider this function from R to R. And suppose if I consider this function, what is sine x from R to R? So is it 1, 1?
Which function?
Sine x.
It is
No,
not
sir.
1, 1.
This is not 1, 1, right? And what about onto?
Not on.
Not
No,
on.
sir. Not on.
Not onto, right? So this is not, because sine x is, of course, is in between what 1 to
Minus 1 and 1.
minus. Okay, so there are a lot of points which you are missing. Okay, so now let's move to week 2. And yeah, so basically in week 2, you have studied about straight line, right? And in this straight line, so yeah, so one of the main tasks is to find the equation of the straight line, right? So you have this, let's say you have this, suppose this point slope This is probably the most important way to find the equation of a straight line. So if it doesn't matter in which form, you can always bring that one into this form, right? So what basically it says, so it is given that the straight line, so suppose you have a line L, this passes through a point, right? And the slope of the line is m, right? So then what will be the equation of the straight line, right? So how you can get the equation of that straight line?
Y minus y1 is equals to mx minus x1.
So this is your x0 and y0. If I pick any point in this line, then I should, if I take the difference of this y-axis and quotient with the x-axis, so what I will get, y minus y0 divided by x minus x0 is
Equal to
m, right? So that means y minus y0 is equals to m times x minus x0, right? So yeah, so why actually I'm saying this point slope form. So it doesn't matter which form it's given, like it's 2-point form or slope intercept form or the intercept form. You can always bring that one into this point slope form, and you can compute the equation of the line. So it's probably the easiest way to compute the equation of the line. So eventually what you will get, y equal to some mx plus c, right? If you like what, if you take, then what you'll get, mx x0 plus y0, right? So this part is your c. So this is slope. Again, you are coming into slope intercept. Okay, so this is one of the important way of finding the equation of the line. And once you have this, then so the next thing, important thing in week 2 is your SSC, right? So how you can find some square error. So suppose you have a bunch of data, right? Xi and yi, let's say 1, 2, 2, 3, and let's say 3, 4. And what you want with respect to this data, you want to find the sum square error with respect to some line y equal to mx plus c, right? Then what will be the formula for this sum square error? Anyone? So how you compute the sum square error for when some bunch of data are given with respect to a line?
So summation I start from 1 to 3 yi minus mxi minus c ka whole square.
Correct. Yi minus mxi minus c whole square. So here the number of points are basically 3. So that's why we're taking this as 3. So if some arbitrary is given, you can take I from 1 to m, right? So this one will give you the sum square error of this line y equal to mx plus c with respect to this data. So let's suppose you consider this line y equal to x plus 7, right? And what we want to find the sum square error of this line with respect to this given data, right? So let's try to find the sum square error of this line with respect to this given data. So first, what do we need to do? What is y1? So if I apply this here, what I should get yi minus x minus 7 whole square from I equal to 1 to 3, right? So if I expand this, then what I will get, the first one is basically, oh, this is xi. So first, what I should get? I should
Y1
get
minus x1
y1
minus
x1
x1 minus 7 square
square
plus y2 minus x2 minus 7 square plus y3 minus x3 minus 7 square.
right? So what is y1? Y1 is 2, right? Y1 is 2 minus 1 minus 7 whole square, right? Because my x1 is 1. And what is y2? Y2 is 3. 3 minus 2 minus 7 whole square. And this one is 4 minus 3 minus 7 whole square, right? And eventually what I will get?
6 square plus 6 square plus 6 square.
Yeah. So 3 times c square. Right? So this is this. So whatever value it is, this is the SSE of this line, right? Sum square error of this line with respect to this given data, right? So it doesn't matter what line it's given. You just need to apply this rule. Okay. And yeah. So again, we are not doing. We are not finding this SSE for fun. Okay. So that there is. Yeah. So there is a region. We basically want a best fit. Okay. For a bunch of data. Okay, so next, let's move to this quadratic function and polynomials. So here, actually, I want to spend more time. So, so first, tell me what basically you mean by quadratic function. I guess we have already discussed. So what is quadratic function?
Power 2.
Polynomial of degree 2.
Correct. So it's a polynomial of degree 2, right? That means it should be of this. Right? Where a is not equal to 0, because if a becomes 0, then basically I'm coming back to this quadratic linear equation, right? So I need to make sure that this one is not equal to 0, right? And yeah, so again, so the thing is this, I can treat this polynomial as a map from R to R. Okay. And we have already, I already told you this map is neither
1, 1,
neither 1, 1 nor on, right? So why? So So if I try to draw the graph of this polynomial, okay, so there are two possible cases, okay, and that two possible cases depend on the sign of some number, right? What is that number?
A.
A, right? See this leading coefficient, right? So if A is greater than 0, then my polynomial opens upward, right? So that means you have a parabola like this, and if my polynomial is less than 0, that means this is open
Downward.
downward, right? Now you see, even if it opens upward, so still there are two possible cases, right? Either your parabola can be like this, or it can be like this, right? So how you are going to decide whether your parabola will cross the x-axis or not?
Value of C.
And the basis of vertex.
On the basis of C.
Sorry, on the basis of
Yeah, the x-intercepts.
Sufficiency.
C, yeah. So there are two possible cases through which actually you can do it. So one is either you need to find the you need to find the C, which is the y-intercept, right? Either you need to find the y-intercept, or you need to find the roots, right? That is x-intercept, right? So if all the roots are imaginary, right? So if all the roots are imaginary, in that case, and of course, if A is greater than 0, in that case, the graph will look like this. It will never cross the x-axis, right? And if you have two real roots, in that case, you will get this. And also, like as many of you said, you can actually compute the y-intercept as well. And the same argument holds here. Okay. So now you have this okay. So by using this argument, you can, of course, you can decide whether the parabola crosses the x-axis or not. But there is much more than this. So this parabola is, in some sense, it has a nice figure. So it's symmetry about something. Okay, suppose you have a parabola. So if I try to draw the parabola, and let's say the A is positive. So if I try to draw this parabola, then it is symmetry about some line, right? And this is called the axis of symmetry, right? So what is the equation of this line? What is the equation of this line?
X is equal to C.
No, x is not equal
Y
to
is equal to 0.
y equal to 0. See, y equal to 0 means x-axis, right? This is your x-axis. X equal to C means
X is equal to some constant.
Yeah, of course, x equal to constant, but I want that constant.
Minus C, minus B by 2A.
Minus b by 2, right? So this axis of symmetry is minus b by 2, right? So with respect to, so this parabola is symmetry about this line. Okay, so that means if I know the parabola in this side, okay, if I know the parabola in this side, then actually I can know the parabola in that side as well. Okay, so if this distance is L, and if this distance is also L, then they basically give the same value. Okay, that is what all this symmetry city is about. If you know the parabola in one side, then you can easily know how the parabola behaves on the other side, right? And there is one more special point. So this point, right? What is the coordinate of this point? And what? Oh, so this is this you call vertex, right? What is the coordinate of this vertex?
Minus b by 2a comma 0.
Minus b by 2a comma f of minus b by 2. This is the vertex of the parabola, right? And as you can see, if I project all these points, okay, if I project all these points on my y-axis, then I will get all the points above this point, let's say M. Okay, I'll get all the points above this point A, right? So that means, and what is this point? This point is precisely f of minus b by 2a, right? So all the points which are above f of minus b by 2a, they are inside the range, right? And so if a is greater than 0, then all the points which are above f of minus b by 2a are inside the range. So that in that case, the range of this parabola is f of minus b by 2a to infinity, right? And if a is negative, then I have a parabola like this, right? And this point is what? This point is minus b by 2a and f of minus b by 2a, right? And all the points which are below this point is all the points which are below. Okay, I guess I made a mistake. Let me draw like this. Let me draw like this. Yeah, so this is my axis of symmetry. So if I project, what I will get? I will get all the points which are, and this point is what? 0, comma f of minus b by 2, right? So if a is negative, then the range of the parabola, range of f is basically minus infinity. All the number which are below, of this point. Okay, minus infinity to f of minus by. Please mute yourself. Okay. So this is the range, right? So any doubt so far?
Sir, can you please take some examples from the question paper?
Yeah, anything on your mind? Please tell me. Otherwise, I can certainly look into the but again, you tell me, right? You just give me example. Okay, let's. It doesn't matter. Let's say this one, x square plus x plus 1, right? So what is the coefficient here? What is a? Here a is greater than 0, right? Please mute yourself. Rajkumar. Yeah. So a is greater than 0, right? So, and what about the roots of this polynomial? Is it real, complex? What are the roots of this polynomial?
So this question is always positive.
I'm asking about the roots. You tell me what are the roots of this polynomial? Is it real?
Sir, imaginary.
Imaginary, right? So in that case, I'll get like this, right? And so because see, this is certainly opens upward because a is positive, and as well as it doesn't, certainly it's not going to cut the x-axis because this quadratic equation has no real roots. So that means it will always lie above the x-axis, right? And what about the axis of symmetry? What is the axis of symmetry for this quadratic equation? X equal to minus b by 2a, right? And if I compute, what I will get? Minus 1 by
2. That is 0.5. Minus
2,
0.5.
right? So that means, okay, that means I am not drawn it correctly. So this line, is my axis of symmetry, right? So let's say should look like this. So this is my axis of symmetry, x equal to minus half, right? And what is the vertex of so what is this point? So this is vertex, right? And this point is minus b by 2a and f of minus b by 2a. And I have already computed the vertex, right? Or the x coordinate of the vertex, right? This is minus half. And the next thing what I need to compute, f of minus half. This is what? 1 by 4 minus half plus 1. What is this value? This is 1 by 4.
3 by 4.
3 by 4. Correct. Right? So this point is minus half comma 3/4, right? And see, the thing is, this is a parabola opening upward. It has a minimum value, right? It has a minimum value, right? Right? And where the parabola actually attains its minimum value at the vertex, right? And at the vertex, the value is 3/4. So the minimum value of this parabola is 3/4, which is precisely this one. So this is your 0, 3/4, right? And the parabola attains all the value which all the numbers which are above this 3/4, right? Because you project this point, you project this point, you project into this point in this y-axis. So all the points which are above this 3/4, they are inside the range of the parabola. And this 3/4 is the minimum value of the parabola. So that's why the range of the parabola is 3/4 to infinity. Okay. See, the only difference here, since this is a parabola opening upward, so of course it will have a minimum value. And when you have a parabola opening downward, here you have a maximum value, right? And when you have a maximum value, that means the range will certainly will be in this form. Okay. So if your range in this form, then only you have a maximum, right? And when your range is of this form, in that case, you have a minimum value. Okay. Okay, any doubt so far? Okay.
No, sir.
Yeah. So again, next, let's move to polynomial. Okay. And there is only one thing actually I want to discuss about the polynomial, that if a polynomial is given, how you can draw the graph of a polynomial. Okay, which is okay. So this is really important in the exam point of view. So again, the thing is, you can't draw any arbitrary polynomial, right? You must know all the roots of the polynomial. Then only you can draw the graph of that polynomial. So suppose, let me start with a polynomial p of x is x minus, let's say, x minus 1 whole square, x minus 2, 3, x plus 5 whole square, x plus 7 whole cube. So this is my polynomial, right? And I want to find, I want to know the graph of the polynomial. Okay. So the first thing what I need to understand, what are the roots of the polynomial, right? What are the roots of the polynomial? So as you can clearly see, this polynomial has only 4 roots, right? Minus 5,
minus 7, 3 and 1.
1, right? And the next thing is, I want to know about the multiplicity of this. Okay, because when I draw the graph, then I'll say why actually we need this multiplicity.
Hello.
Yes.
I have not yet gone through this in the tutorials.
Mm-hmm.
So can you please tell me how the roots are calculated?
Because it's given, it's it's given, right? It's already given in the polynomial, right?
Okay, yeah.
See, the thing is, I said in the beginning that you simply can't draw any polynomial. Okay. So until unless you don't know the roots, then you can't draw. Okay, and in most of the cases, in the question will give you the roots. Okay, so if I give you some arbitrary 10-degree polynomial, it's really difficult for you to compute the roots. Okay, so in most of the cases, this polynomial will come with its root. Okay. So, okay, so what is the multiplicity of -5?
2.
2, right? Because as you can see, this x plus 5 is appearing twice, right? So the multiplicity is 2. And what is the multiplicity of -7?
3.
3, right? And the multiplicity is 1 for
And
3. And this is
1.
2, right? Okay. So the next thing is, so this is roots and along with the multiplicity. And the next thing is the end behavior. Okay. So I want to know where this polynomial goes as x tends to. So as x tends to plus infinity, where this p of x actually goes. And similarly, when x is going towards minus infinity, where this p of x goes. Okay. And see the eventually, so to draw the graph, you need end behavior in only one side. Okay. Either you know this one, or you need this one. Okay. You don't need both the end behaviors. Okay. You just need only one end behavior. Okay. So we'll see why one. So if you know the behavior of the polynomial in one side, that is actually enough. So first, and one more thing is the end behavior of this polynomial is completely depends on the end behavior of the leading term of the polynomial. So what is the leading term of this polynomial? What is the leading term of this polynomial?
Leading term is -5.
X plus 7 the whole cube.
X की power 8.
2, 3 plus 5, 5, yes. So if you multiply, when you don't have to multiply, so here what you will get? Here the leading term will be x square, right? If you expand this, you'll get x square plus something, right? So the leading term is x square. Here the leading term is x, right? Here the leading term is again x square. Here the leading term is again x cube, right? So if you multiply all the leading terms, then in the end you will get the leading term of the polynomial, which is x8. And apart from, you will get some other term, which of course we don't care, because the end behavior of the polynomial, okay, it's completely depend on the end behavior of the leading term of the polynomial, which is x power 8. So as x tends to plus infinity, this x power 8 will go towards where?
Infinity.
Correct, plus infinity. And as a result, the whole polynomial will go towards plus infinity, right? And similarly, if x is going towards minus infinity, where this?
Plus infinity.
Correct. Again, it will go to plus infinity, and this p of x will go to plus infinity. So in both the sides, as you can see, again, we don't need both these two information. One information is enough. And you can see actually in both the sides, it's going towards plus infinity. So now we can easily draw the graph of the polynomial. So, okay, let me start with the right hand side, right? With the right hand side. So as you can see, see this right hand side means what? Here, if you move along this x-axis, so this here x is going towards plus infinity, right? Correct? And when x is going towards plus infinity, your p of x is also going towards plus infinity, right? That means the value of the p of x is positive. It's going towards infinity, right? So if I try to draw the graph of the polynomial, so as you can see, I have only 4 roots, right? So 3 is a root, 1 is a root, -5 is a root, and -7 is a root, right? So of course, if I try to draw the graph of the polynomial, then the graph certainly it will come to this point, right? This, because 3 is a root. So now when you start drawing, so you have 2 cases. Either this polynomial can come from the below, or it can come from the above. But as you can see, this polynomial cannot come from the below, because as x is going towards plus infinity, this polynomial is also going towards plus infinity. So if the polynomial is coming from the below, that means this p of x is going towards minus infinity, right? Which is not happening in our case. Okay, so that means it cannot come from the below side of this x-axis. Okay, so it has to come from the above. So it will come till here. Now you have 2 choices, right? Either it can cross this point, right? Either it can cross this point, or it can bounce back, right? There are 2 possibilities. So either it can cross this point, or it can bounce back. So to decide this thing, you need multiplicity of the root 3. So if you go back and see, the multiplicity of this root 3 is 1, right? Which is odd, right? So if the multiplicity is odd, then it will cross the x-axis. If the multiplicity is odd, again it will cross the x-axis. So it will cross this point, and again it will come back to 1, right? And again, to decide whether it will cross this x-axis or bounce back, again we have to go and check the multiplicity of 1. So the multiplicity of 1 is 2, right? It's even. Since this is even, it will bounce back. Bounce back, and again it will go to 5. So the same thing arises here. So whether it will cross this point, or again it will bounce back, for that we need to go and check the multiplicity of -5, which is again even. And as you can see, again it will bounce back, and it will go to -7. And in the -7, as you can see, the multiplicity is 3, which is odd, right? So that means it will cross the x-axis. Okay, so the graph of the polynomial will be more or less similar to this graph. Okay, so once you have this graph, from here you can easily compute the number of turning points. Because why you want to draw this graph? Because this will give you the number of turning points. As you can see, this is a turning point, 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 and this is a turning point. So 1, 2, 3, 4, 5, right? So this polynomial, whatever I have written here, this polynomial has 5 turning points. Any doubts so far?
No, sir.
Okay. Yeah.
Is there an assignment for qualifier?
Sorry?
Is there any assignments for qualifier exam? For
So
diploma in programming?
so have you got the question paper? You must have got the question paper, right? Week-wise question paper.
Yes, sir, but I got only one mail from the IIT.
Not for the diploma applicants, sir.
Yes, sir. My current course also showing empty. Nothing in my dashboard.
Yeah, certainly there are a bunch of questions, like assignment paper. I don't know whether they have shared with you. Yeah.
Seems
So
like for the diploma applicants, there is no assignments or the weekly classes. We are actually going through the video lectures
Yes, sir. YouTube
ourselves.
only we are studying. I didn't know what you're talking about. I just stopped with
It
the
is only
functions.
actually for, so we are actually going through those video lectures by ourselves. So that's why we are not able to follow much of what you were actually saying, but this should be helpful when we actually connect these through to the video lectures.
okay, so again, like there are question paper. I'm not sure. I certainly there is not a single file that I can give you. It's better if you write a mail to the course support.
Right. So one other thing that we'd like to confirm is it seems like there is 100+ video lectures out there, and we're having the exam on the 30th April this month. And would you suggest to go through all those video lectures, sir, or is there any particular things that we should be keenly going through? Because we don't know how much of choice that we'll be having in the question papers. So just trying to understand the pattern of the question papers or the syllabus.
Yes, sir. We have to understand.
Yes, sir. For diploma holders, it is quite difficult. It's very less time remaining.
Yeah, but again, like the thing is, the syllabus is from week 1 to week 11. So yeah, so it's not that we have gave question from a particular week. Okay, so mostly we'll see question from all the weeks.
Is there any topics that we should be keenly looking at, that as you're saying, like this parabola topic should be something that we need to look for on the exam time, like you were saying here?
Like the maximum questions will be on which topic like that?
No, as far as I remember, the questions are mostly uniform. Right? See, yeah, so week 1 to 4, week 4 to 8, week 8 to 12. Okay, so if you see, the question are sort of uniform. Okay, so 30% you can see. And you have question from all the weeks.
We will be
So what
receiving
will be-
those questions, sir? Are you saying that we'll be receiving those 30 questions?
Sorry?
Are you saying that for week till week 4 we'll be receiving 30 questions, and from the
Not 30 question, I'm saying the percentage.
okay, percentage.
Yeah.
So what will be the weightage of mathematics for the qualifier exams? Marks weightage.
Okay, that I certainly don't remember. Okay, so
I think it is for each subject we need to have a 50%, and overall percentage should be 40%, something like
okay,
that.
so yeah, so
On
let me
it's opposite. Okay, sorry, I did it in the opposite way. Sorry.
okay, so so before that, let me finish. I planning to, at least I am planning to revise till week 6. Okay.
Yes, sir. Yes, sir. Please continue.
Okay, so
Sorry,
after that,
sorry to other participants that we might have asked questions.
so yeah, once I finish, then probably I can ask. You can ask bunch of things, whatever you like. But yeah, again, like see, the 2 sessions, it's really difficult to go through all the contents. Okay, even it's really confusing for me to also. Yeah.
So one simple question would be, since we haven't attended any IIT exams, to do all these workouts about these formulas and the steps in the maths, will they give any workout sheets on the exam, sir?
That will do.
Thank you very much.
Okay, so week 5. So again, see, the weak pipe is kind of okay. Some portion is kind of it's basically the same thing that you have studied in week 1. So the first thing that basically is the first concept of weak pipe is 1-1 function. So 1-1 function, and again, you know what is 1-1 function, and you suppose you have a map. A to B, right? And when you say this function is 1-1, again, if the inputs are different, then this should imply that the output are also different, right? In that case, you say this function is 1-1, and if you know the graph of the function, then by looking at the graph, you can so if you have a graph, then actually you can apply this horizontal line test, right? So this is the horizontal line test. So if the horizontal line crosses the graph at 2 points, if you have a horizontal line which crosses the graph at 2 points, then you say this function is basically that. This basically means that you have 2 points x1 and x2 for which the value are same, right? So that means this function is not 1. So, but if you have a graph like this, so here it doesn't matter which horizontal line you take, it always crosses the graph of the function at max 1 point, right? So for this case, it crosses exactly at 1 point, right? So in this case, so this function qualifies the horizontal test. That means this is a 1-1 function, and whereas here this horizontal line test fails, that means not 1. And one other reason why actually we are studying this 1-1 function, because this 1-1 function has something to do with invertibility. Okay, so okay, so the reason, again, the reason why we're studying, because if you have a 1-1 function, then somehow you can find the inverse, of course, with some other condition. Okay, so you need to restrict the codomain, right? So suppose you have a function A to B, right? And f is 1-1. F is, let's say, 1-1, right? So once I know that this function is 1-1, then I can talk about its inverse, right? So, and how I can talk about this inverse? I have to make sure what is the range of this function. Okay, so if the range of f is B, then basically it's both 1-1 and 1. Okay, if the range is not B, okay, let's say the range of f is, let's say, some C, which is a subset of B. Okay, still I can, in that case, still I can talk about the inverse. So in that case, I'll have a map f inverse which is from C to A, right? So in that case, I'll have a map from C to A such that f compose f inverse is identity, which is also same as f inverse compose f. So if the range is equals to the codomain, in that case it's sort of obvious. So in that case you'll have a map from B to A. But if the range is not B, it's a subset of B, in that case you have an inverse from C to A. Okay, so that is one of the advantages of this 1-1 function. So that's why so in this week we are focusing on 1-1 function. Okay, so okay, so let me take an example. So let's say you have a function like this. Right. So do you think this is a 1-1 function? What, first tell me what is the domain of this function? What is the domain?
Except 2 by 3 all real numbers.
Right. 2 by 3 all real numbers. Right. So this is the domain. And once I have this domain, so my question is whether this is a 1-1 function. So 1-1 function means what? If f of x is equals to f of y, let's say f of a is equals to f of b, this would imply that a is equals to b, right? So do you think this holds for this function? If f of a, that means 4a plus 5 by 3a plus 3a minus 2
Is equals to
what? 4b?
4b plus 5 upon 3b minus 2.
So if these are same, then if somehow if I am able to show that if I'll be able to show that this a is equals to b, then my function is 1. So can I show from here? Can I show that a from here? Can I show that a is equals to b?
No.
Okay, so what you do, you try to cross multiply. Okay. Now you try to simplify the whole expression. From here, actually, you can say you can get a equals to b. You try to multiply and you can cancel it out. Okay. You try to do it. Okay, it's not difficult. You just need to multiply the things. So this function is 1, right?
It's 1-1 function.
Yeah. So to find the inverse, what I need to do, I need to find a function g of x. Okay, we'll decide from where to where. Okay. It's basically square. So such that this f compose g of x and g compose of x is x, right? So okay, so let's start with this part, that f compose g of x is x. That basically means we want a function g from some set to R which satisfy this condition. And what is this? This is f of g of x, right? Which is equals to x, right? And let's denote this g of x by y, right? For the simplicity. Okay, we don't want to write so many notations, so it's so many things. Simply you write this as f of y equal to x. So if I write f of y equal to x, then what is f of y? What is f of y? What is f of y?
4x plus 5 upon 3x minus 2.
See, 4y, right? 4y plus 5 by 3y
Minus 2.
minus 2, which is x, right? So now what you will do, correct?
Yes.
Now, if you put all these things, this y term on the left, what you will get? What you will get on the right? Minus 2x
Minus
minus
5, right? So if I take y common, then what I'll get? 4 minus 3x minus 2x minus 5, right? And this y is nothing but minus of 2x plus 5 divided by 4 minus 3x. And if I multiply minus, what I will get? 2x plus 5
Upon 3x minus 4.
3x minus 4, right? So what is y? Y is precisely g of x, right? So my g of x is 2x plus 5 divided by 3x minus 4, right? So this is what we initially we have taken, right? So this we have computed by using this relation, right? And also you can check whatever I have. So whatever we got here, okay, this g of x, this also satisfy this condition as well. You have to do it separately, the same procedure. So that's why this function g of x is the inverse of f of x. And what is the domain of this g of x? R minus
4 by 3.
4 by 3.
4 by 3. Correct. So initially I asked you, right, how to. So once you get the expression from there, actually you can easily compute the domain. So this g is nothing but f inverse. Okay. And this is the standard way of computing the inverse of the function. So you can actually compute in this way. You can compute inverse of almost all the functions, not almost all, at least almost all the functions that we are using in week 5. Okay. Okay, so so again, there is why. So why actually we are interested in finding the inverse? That basically it's sort of related to this exponential function. Okay, because we want to talk about logarithm. Okay, and what is logarithm? Logarithm is nothing but it's the inverse of an exponential function. Okay, so that's why we are interested in finding inverse of function. So what is logarithm function? Sorry, what is exponential function? Anyone? What is exponential function? What is the definition of exponential function?
So that involves E.
Sorry?
That involves something raised to power.
So if you have a function of this form, x right? Then you say this function, so where a is greater than 0
and a is not equal to 1.
right? So in that case, so here we are taking this function from R2, right? So in that case, if you have a function which is of this form, in that case you say the function is a exponential function. Okay, so for example, I can take this function f of x equal to 2 of x, or f of x equal to 0.5 of x, f of x equal to some e power x. Okay, so all such type of function, they are exponential function. Okay, so as you can see so there are two behavior. Okay, two behavior of exponential function depending on the value of a, right? So if I keep increasing the value of x, then this whole thing will increase, right? Because I have 2 here. But whereas, so here this is nothing but 1 by x, right? So but if I increase the value of x, then the value of this function will decrease, right? Because you have a number which is less than 1. This is a fraction, right? If I not fraction, okay, even 4 by 3 is also fraction, but here I have a number which is less than 1. Okay, so if you have a number which is less than 1, and if I increase the power of that number, then the whole number will decrease. Okay, so that is so there are two behaviors of this exponential function. So if I try to, whatever I said, if I try to draw the graph, okay, so how it will look like? How it will look like? Any idea?
For positive x value, it will increase, and for negative x value, it will decrease.
See, if a is greater than 1,
Yeah.
right? So if a is greater than 1, then the graph will look like this, right? So this is 0, 1, because a power 0 is always 1, irrespective what a is. If a is greater than 1, also a power 0 is 1. If a is in between 0 to 1, also a power 0 is 1. Okay, as you can see, this is increasing, right? If you are increasing, if you increase the value of x, the value of the function is increasing, right? So, and what is the reason? Because here a is greater than 1, right? But you have a slightly different behavior when your a is in between 0 to 1, right? So the value will decrease, right? So as you can see, if I have 1 by 2 power x, if I increase the value of x, let's say x equal to 100, what I'm getting? 1 by 2 power 100, which is very small number, right? So if I increase the value of x, so when a is in between 0 to 1, if I increase the value of x, then the whole thing will decrease. Okay. So, but the thing is, both the function, if you try to see the graph, both the function are 1, right? Both the function are 1, right? So, and if you think about the domain and range, so this function is from where to where? So the domain is R, right? And what is the range of this function? What is the range of this function?
0 to infinity.
Correct. So the range of this function is 0 to infinity. So this is an increasing function. This is also 1, and yeah, so increasing function is a special. So this is an increasing function. Okay, strictly increasing, more precisely. It's a strictly increasing function, and that's why this is a 1, 1 function, right? This is a 1, 1 function, and similarly, this is a strictly decreasing function, and this is also a 1 function, and both the function, they are from the set of real line to this positive reals. Okay. So since this exponential function is 1, then I can talk about the inverse. Okay. So once I have a 1 function, then I can talk about the inverse. And what is the inverse of this exponential function? That is precisely the logarithm function. Okay. So logarithm function is what? Logarithm function log base A is a function from 0, infinity to r, right? So as I said, log is the inverse. So here the role of domain and codomain will interchange, right? So for exponential, the domain is r and codomain is range is 0 to infinity. Okay. So now, since this log is inverse, so the role of domain and range and domain will interchange. So now this will become the domain and this will become the range of the function. Okay. So and if you try to draw the graph, again, you have two possibilities. If A is greater than 1, if A is greater than 1, see, if A is greater than 1, here this function is increasing, right? F of x equal to a power x is increasing. So inverse of a increasing function is also increasing, right? So in that case, what you will get? The graph. So you know the inverse is inverse of, if you try to draw the inverse of a function, it's basically the graph is symmetry about y equal to x line, right? So in that case, you will get a graph which looks like this, right? So this is the graph of f of x equal to log base x. And as you can see, the domain is, this function is defined only on the positive side of x-axis. Okay. And again, it's an increasing function, right? Because since f of x equal to a power x is increasing, in this case, the inverse is also increasing. Now, if I consider the reverse case, so here, as you can see, this is a decreasing function. Here also, again, you will get a decreasing function. If your A between this, then you will get a decreasing function. Okay. So this is the graph of AX. Okay. So the inverse actually preserves this increasingness and decreasingness. Okay. If F is increasing, then F inverse is also increasing. If F is decreasing, this F inverse is also decreasing. Okay. So one of the main theme of this okay. So if you, I don't know, again, like many of you have not seen the question. So one of the main thing is you need to find the domain. Okay. Some twisted log function. Suppose I have a function like this. So I know if I have a function like this, let's f of x equal to log, let's say 10x, right? So from here I can say that, okay, the domain of this function is basically all the x, so that x belongs to this, right? So this domain, I can clearly say that the domain is R plus, right? This interval. If I twist this function in this form, x minus 7, right? Then what will be the domain of this function?
7 to infinity.
Yeah. So what we want? So here actually what? Here we have only x, right? And we want this x to be positive. But here instead of x, I have x minus 7. So I want this x minus 7 to be positive, right? X minus 7 to be positive. That means x should be greater than 7. That means x should be in between 7 to infinity, right? So again, this is a easier case. Suppose I have, let's say I have a function like this. Then what will be the domain of this function? Now, as you can see here, we have only x. Here we have x minus 7. Now, here we have this whole thing, right? Now, I want this to be greater than 0, right? Now, what I want this log square this 15 to be greater than 0. Okay, so certainly this expression looks familiar to you, because if I take my m, this log 10x to be m, then what I will get? I will get m square minus 8m plus 15 to be greater than 0, right? And what are the roots of this equation?
Three and 5.
Correct. M minus 3, a minus 5, which is greater than 0, right? So when, under what assumption this expression is greater than 0?
When m is greater than 5.
When m is greater than 5 or m is less than 3, right? That means when log, what is m? M is log 10 log x base 10, right? If this is greater than 5 or is less than 3, right? That means x is greater than 10 to the power 5 or x is less than 10 to the power 3. That means x is in between 10 to the power 5 to infinity, or x is in between minus infinity to 10 to the power 3, right? So the domain of this function is nothing but minus infinity 10 to the power 3. This is minus infinity union.
M is less than 3.
Yeah. If m is less than 3, what is m? This is nothing but log x base 10, right? This is less than 3. That means x is less than 10 to the power 3. So this is precisely the region. So x is either in this region or in this region, right? So that means I have to take the union, right? Yeah. Okay. So any doubt from so far?
Yes, sir.
Yeah. What is your doubt?
Sir, R positive is equivalent to 0 to infinity.
Yeah, positive means zero excluding. Okay, 0 to infinity. This is positive, because 0 is neither positive nor negative. Okay. So when I'm saying all the positive numbers, that means 0 to infinity. When I'm saying all negative numbers, that means minus infinity to 0. Okay. When I'm saying all non-negative numbers, that means 0 to infinity, because I'm excluding the negative numbers. Okay, any doubt? Okay, so this is what I planned till week 6. So maybe tomorrow I'll start from recalling the concept of calculus and some graph theory. Okay, if you have any doubt, you can ask.
Sir, is anti-symmetric or asymmetric both are same or both are different?
Okay, I certainly don't remember the definition of asymmetry. Can you tell me the definition of asymmetry? Then probably I can tell you the difference. What is the definition of asymmetry? If you can tell me the definition, then certainly I can tell you the difference. Okay, I don't remember the definition of asymmetry. Do you remember the definition?
Sir, I think the definition which I gave you for anti-symmetric was for asymmetric. If A comma B belongs to R, then B comma A does not belongs to R.
Yeah, asymmetry is opposite of symmetry.
So you are saying if A comma
B belongs to R, then B comma A does not belongs to R.
yeah, then see if this is the definition of asymmetry, okay, then as you can, so it's clear, right? The asymmetry relation and anti-symmetry relation, they are different. Why? See, anti-symmetry relation is saying what? If A comma B is in R,
And B comma A is in R, then A equal to B.
A equals to B. So for example, if I take this relation 1, 2, right? Let's say not 1, 2, 1, 1, right? This is not asymmetry, right?
Yes, sir.
This is not asymmetry, right? Because A comma B is there, B comma A is there, right? This is not asymmetry, but this is anti-symmetry, right?
Yes, sir.
So certainly they are different. And there is a huge difference between asymmetry and anti-symmetry.
Got it, sir.
Yeah. Any other doubt? Okay, so then I'll stop the session, and tomorrow we'll meet at the same time. And yeah, so mostly I'll discuss again. So I'll be as brief as possible, because if I try to go each and every details, then yeah, it's not possible for me to complete even one. Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.